Okay, students, my apologies. This is the fourth time for me teaching this lesson. I'm wearing my microphone, and if I forget to press the button, it stays red, and that means it's off. If it's blue, it means it's on, and so it was red when I last did this recording. We'll get it right this time. We want to talk about integrals, so things that look like this, and we want to look at integrals that involve the exponential function, and integrals that are of what we call logarithmic form. The antiderivative of e to the x is nice and simple. It is e to the x. Remember, because it's an indefinite integral, meaning it does not have bounds, that we add the plus c on the end. We're looking for a general antiderivative. And the antiderivative of 1 over x is the natural log of x. We put an absolute value because you cannot take the natural log of a negative number. So there you have it. These are our two that we're going to use as a basis. As we find these antiderivatives, we are going to also use our substitution rule in many scenarios. So the antiderivative of e to the 4x, we say u is equal to 4x. Therefore, du is equal to 4 dx. I don't have a 4, so I have 1/4 du is equal to dx. My substitution is now complete with a 1/4 du. I have my integral that allows me to get rid of the dx. What remains? I have e, and u takes the place of the 4x. So 1/4 integral e to the u du. The antiderivative is, in fact, e to the u, or e to the 4x. Attach the 1/4 on front, and a plus c, and that is that. Letter B, we have a slightly different form. You can see that this is a fraction. This is going to be the form of 1 over x. Except we will set up substitution by saying that u is equal to 3x plus 1. Therefore, du is equal to 3 dx. I don't have a 3. Divide by 3, get 1/3. Du is equal to dx. So my substitution is 1/3 integral du. I get rid of the dx. I'm left with 1 over u. Because remember, 3x plus 1 is u, and that goes right there, so 1 over u. The antiderivative of 1 over u is natural log. I plug u back in, I get 3x plus 1. Absolute value, so we do not have a negative, and plus c on the end. Letter C, u is equal to x cubed. Du is equal to 3x squared dx. I don't have a 3x squared, I have a 4x squared. So I'll multiply by 4 and divide by 3. Notice in this situation I have the 4 over 3 integral, and I have a du. That gets rid of the 4x squared and the dx. Notice that x cubed is u, so I have e to the u. The antiderivative of e to the u is e to the u, or e to the x cubed. Letter D, I allow u to be 2x minus 9. So du is equal to 2 dx. I don't have a 2 dx, I have an 8 dx. So therefore, 4 du is equal to 8 dx. Those are now gone with my 4 integral du. What remains? That thing is u. So I have 1 over u. So 4 natural log of, and u is 2x minus 9. Letter E, we're going to switch this to a 5. Notice this is a definite integral, so we will come up with a numerical value. First, I must find an antiderivative for 2 over x minus 3. Then I will evaluate it at 8 and 5. U is equal to x minus 3. Notice that du is simply just 1 dx. We need the 2, so 2 du is equal to 2 dx. But when you end up with this, the antiderivative becomes very straightforward. You're going to see that you would have been able to predict it from the beginning. So we have this piece right here. I have integral 2 du, gets rid of those. I'm left with 1 over u. And the antiderivative of 1 over u is natural log of u, and u is x minus 3. We're going to evaluate that at 8 and 5 because of our definite integral. I plug in 8, I have 2 natural log of 5 minus 2 natural log of 2. Hopefully you remember that what you can do is you can take two logarithms that are separated by subtraction and rewrite them using division and one logarithm. This answer is acceptable. The other answer that's acceptable is maybe you realize you can also dump the 2 up there as an exponent. That would create natural log of 5 squared, which is 25, and 2 squared, which is 4. So either one of these are acceptable for an answer, but you should write it as one logarithm if possible. Letter F, let u be e to the x minus 1. That means that du is equal to e to the x dx. Integral du, 1 over u. Antiderivative 1 over u is natural log of u, or natural log of e to the x minus 1. We're going to evaluate that at 4 and at 2. Watch what happens in this situation. We have the natural log of e squared, or e to the 4th, excuse me, minus 1, minus the natural log of e squared minus 1. If you write it as one logarithm, you get the natural log of e to the 4th minus 1 over e squared minus 1. And we're not done yet because that factors e squared plus 1, e squared minus 1 over e squared minus 1. Those are gone. The natural log of e squared plus 1. That's what we have. As we move forward, let's look at two that are a little bit more complicated. This one looks extremely complicated until I rewrite it as 3x to the negative 5th times e to the x to the negative 4 dx. So notice this 1 over x to the 4th is the same as x raised to the negative 4th power. U is equal to, in this case, x to the negative 4. Du is equal to negative 4 x to the negative 5 dx. Notice how you have the x to the negative 5 and the dx. You need a 3, you need to get rid of the negative 4. So 3 over negative 4 du is equal to 3x to the negative 5 dx. That's my substitution. That will make this complete. That gets rid of this guy and this guy. I'm left with e to the u. Antiderivative of e to the u is e to the u. And u in this case is x to the negative 4th, or 1 over x to the 4th, plus c. This next one looks very complicated. It's not too bad. U is equal to the natural log of x. So du is 1 over x dx. Notice in this situation that we have a 4 in the denominator, so we will multiply by 1/4. That way the 4 will be in the denominator. So 1/4 du is our substitution. When we do that, we get rid of the 1/4 x dx. We're left with this thing squared, that is u squared. And the antiderivative of u squared is u cubed over 3. So we get the natural log of x cubed over 3 times that 4, so it'll be a 12 in the denominator, plus a constant. I looks very challenging. It turns out it's one of the easiest problems of all. One of the tricks to the trade here, substitution does not work, but is to simply divide. The integral of 3x squared over x is going to be 3x. And then 4x over x is 4. And then 2 over x is 2 over x. So I just rewrote it. I didn't take an antiderivative. Now as I take the antiderivative, the antiderivative of 3x is 3x squared over 2. And the antiderivative of 4 is 4x. And the antiderivative of 2 over x is 2 natural log of x, plus a constant. J is different because there's a binomial in the denominator. Let's divide. What do you multiply x by to get x? You multiply by 1. So we have x minus 1, and we subtract. 1 minus negative 1 is 2. We have plus 2 over x minus 1. So we rewrote the problem to be the integral of 1 plus 2 over x minus 1. The antiderivative of 1 is x. The antiderivative of 2 over x minus 1 is simply just 2 natural log of x minus 1. If you use substitution, you can do that. You'll come out with that answer. We have 2 left. In this case, u is equal to 3 plus cosine of x. The derivative of 3 is 0. The derivative of cosine of x is negative sine of x dx. You do not have a negative, so we have negative du is equal to sine of x dx. Notice how that takes care of the sine and the dx. So I have negative integral du. I have a 1 in the top, and in the bottom I have u. The antiderivative of 1 over u is natural log. And for letter L, u is equal to the root of x minus 2. The derivative of the root of x minus 2 is 1 over 2 roots of x dx. Notice how we have a 4 in the denominator, so we go 1/2 du is equal to 1 over 4 roots of x dx. I now have that substitution. U is the root of x minus 2. Piece of cake, upside down. You've seen 12 examples. That should be sufficient to be able to do your work. The answer key is posted. Please reach out if you have questions. I'd be happy to visit with you. Short, 13 minutes.